Hi, I wanted to talk to you for just a few minutes about Ethernet. This is a really important concept when talking about in terms of encapsulation and framing. So I'm going to jump right into it here. Now, if you'll look at this slide here, we're looking at Ethernet encapsulation. Now, notice this. So if you're looking at your OSI model for review, you have your 7 layers here. Notice something that you may not have seen before. So the data link layer is unique in terms of the other layers because it actually has 2 sublayers. So there's the LLC and the MAC sublayers. So your data link layer is broken into these 2 layers. The LLC works with the software, so it works with the network layer and the software, so the layers above that, and then the MAC sublayer works with your hardwares. The MAC sublayer, this is where you'll find your MAC address on your NIC. The NIC works with the hardware, and really that would mean your cabling in terms of your physical layer. So your Ethernet layer actually goes and works closely with the MAC sublayer down, so half of your data link layer. If you have trouble remembering the order, remember L before M, alphabetical order, and that'll help a little bit. So that is where your Ethernet layer resides. Here's another representation of that. So you can see here where the LLC works with the network layer and above, and then your MAC sublayer again works with your physical layer. You see the Ethernet stretches all the way across. Now there's various versions of Ethernet. There's older versions and there's newer versions. And the speeds represented over here show all the different bandwidths that are supported by Ethernet. And the different bandwidths will are determined by what type of Ethernet that you're actually using, what kind of cabling. So your MAC sublayer is represented here. Your MAC sublayer actually does what's listed in this window. So you have frame delimiting. This is the separation of one frame to the next. You have your addressing. So you also have error detection. Now I'll show you error detection and where exactly it resides within a frame in just a minute. But your error detection actually is used to help determine if there's an error within the transmission process. This is your timeline of Ethernet. So Ethernet's been around for a while, but it's changed a whole lot. So you could actually flip through and look at all the different versions of Ethernet. This is the general sequence of a frame structure for Ethernet. We'll look at it more in depth in a minute, but you have a preamble, the destination address, source address, the type, the data, and the frame check sequence. Let me go over that a little bit more in terms of this. So this is a nice little diagram. It allows you to click interactively on each one of the fields that are listed. So this is an Ethernet frame field, but this is a good one to study because most protocols use the same setup for their fields. So if you learn this one, it'll make it easier if you start learning the other protocols. Your preamble, think of the preamble to the Constitution. So this is the beginning of the frame, and it often includes what's referred to here as a start frame delimiter. So the start frame delimiter says, here's the beginning of the frame. You have your destination MAC address. You know how important that is from the last chapter. So this is where your frame is going. Your source MAC is where it's coming from. The Ethernet type, what version of Ethernet are we using? Then you actually have the data itself, and then the end is the frame check sequence, which I mentioned a minute ago that I would tell you a little bit more about. So here you go. With your frame check sequence, when data exits an interface, it performs a polynomial calculation. You don't have to know how to do that, but just know that it does. When it performs this polynomial calculation, it adds a value right here in the frame check sequence. That is sent along with the data, and then it's received on the incoming interface. That same calculation is performed. And if the device comes up with the same thing that for the FCS or frame check sequence that it received, okay, so the sender and the receiver have the same thing, the receiver can assume that the data was sent properly. If not, if it comes up with a different number, then it asks for the data to be resent. So if you wanted like a real world example of this, about the best one that I can come up with would be if you were a cashier. If you ever worked at a cashier somewhere and you ran a cash register, you know that you may have to ask somebody for money to stock in your cash register. So what's the first thing you would do when you get that? Well, you would count it. So whoever gave you that money would count it. They'd give it to you, you'd count it, and you'd both agree that that was correct before you move forward. If it's not correct, you would want to verify or change it or do whatever you need to do to rectify that situation. So that'd be the best example of a frame check sequence that I could give you. Okay, so I hope that helps a little bit. That's just a short video on that. If you have any questions, please let me know.